Hi everyone. In this video, we are discussing problem number 413, arithmetic slices. It's a medium level lead code problem, and let's read the problem statement. An integer array is called arithmetic. First of all, they're explaining what is the meaning of arithmetic, right? An integer array is called arithmetic if it consists of at least 3 elements. It's a very, very important condition that it must consist of at least 3 elements. It can be anything more than 3, 4, 10, 1,000, it doesn't really matter, but minimum is 3, okay? And if the difference between any two consecutive elements is the same, right? The difference between any two consecutive is the word to note here, okay? Consecutive terms, elements is the same, right? So they have given some examples of arithmetic sequences. You can check this particular array of integers, 1, 3, 5, 7, 9. It's clearly an arithmetic sequence, right? Because we have at least 3, we have 5 to be precise. We have 5 elements here. And what is the difference between the first and the second element? 2. 3 minus 1 is 2. And the difference between the second and the third element is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2, right? So we have the same difference throughout, right? If we find the difference between any two consecutive terms in this particular array of integers, it is exactly 2 throughout, okay? Check this example. Here again, we have an arithmetic sequence, right? This consists of at least 4 elements. This consists of at least 3 elements. We have 4 elements to be precise. And what is the difference between any two consecutive elements? It's throughout, it is 7 minus 7, right? Any term minus its preceding term is going to be 7 minus 7, which is 0, okay? So here, the difference, that common difference is 0. And just one last example. Consider this array of integers. And here we have 4 elements. So it satisfies the condition that there are at least 3 elements. And what is the difference between any two consecutive elements? It is negative 4 this time, right? It's a negative number. Minus 1 minus 3 is minus 4, okay? Minus 5, minus of minus 1 is minus 4. Minus 9, minus of minus 5 is minus 4. You see, so in this example, that common difference was 2. Here, it was 0, right? And here, it is negative 4. So the common difference can be a positive number, it can be 0, or it can be a negative number, right? So these are some of the examples of arithmetic sequences. So now the problem is not just to find the arithmetic sequences. There is something more to it. We are given an array of numbers, right? An array called nums, okay? And we need to return the number of arithmetic subarrays of nums. Now, what is the meaning of subarray? There is a big difference between subarray and subsequence, okay? Subarray means it has to be contiguous, okay? It's a contiguous subsequence of the given array, right? There cannot be any gaps, okay? So it has to be contiguous, or in simple terms, continuous, right? So we need to find the number of arithmetic subarrays of any given array called nums. And here there are some examples given. I'll give you a better example when we go to whiteboard. Okay, example number 1. The given array of numbers, nums, is this 1, 2, 3, 4. Now, do you see that this entire array itself, the whole array itself is arithmetic in nature because the common difference is 1 throughout, okay? And why is the output 3? Why is the output 3? It's very simple, because we need to count the number of arithmetic subarrays, okay? So 1, 2, 3 is a subarray. It's part of this, right? 1, 2, 3 is very much a part of nums, okay? And it is contiguous, right? We're not skipping anything. There are no gaps. So 1, 2, 3 is a subarray, which is arithmetic in nature. 2, 3, 4 is a subarray, again, that is also arithmetic in nature. And the entire array itself is counted as a subarray of the given array. The whole array itself can be counted as a subarray, right? So that way we have 3 subarrays of the given array, which are arithmetic in nature. Yeah, you can take 3 and 4, that's a subarray. But the problem is you cannot call it an arithmetic subarray, because for it to be an arithmetic subarray, it has to have minimum of 3 elements. That's a criteria, okay? Now look at the second example. The given array of numbers is just one number 1. And how many arithmetic subarrays we can have? 0. Because even if I take the entire array itself, it is just having one number, one integer, right? And we need minimum of 3 elements for it to qualify as an arithmetic subarray. So you cannot find any, right? Therefore, the answer is 0. And some constraints are given. The length of the nums array is ranging from 1 to 5000 inclusive, and each and every element in that array, it's ranging from -1000 to +1000 inclusive, right? Okay then, so now let's head over to whiteboard and see how to solve this problem, right? So let's start our discussion with this particular example. I purposely took a somewhat lengthy array for us to see clearly what is going on. Okay, so let's discuss this example. So whatever is our observation from this particular example, we'll try to put it in more formal terms. And once we do that, then we will come up with a strategy and like an algorithm, and then we'll code it out, right? Okay then. So we are going to do one linear pass from the first element to the very last element. Okay, just one linear pass. That is all we need. Okay, 0, 1. Okay, so far the difference is 1 between these two elements. And when I go to the next element, the difference between 1 and 3 is 2. Now the chain is clearly breaking here. 0, 1, the gap is 1. 1, 3, the gap is 2. No, so it is not an arithmetic subarray, right? This one is not an arithmetic subarray. So no, we're not counting it. Can you just count 0 and 1 alone? Even that is not allowed, right? Because you must have minimum of 3 elements, okay? So you can't just count 0 and 1 alone, and nor you can go ahead and count 3, because then it is not arithmetic in nature, because the difference is not constant anymore. Okay, so we drop that idea. We drop it. Now we'll start afresh at this particular point, okay, from 1, okay? So we keep moving right. We take the next element, 3, so the gap is 2, and we need minimum of 3 elements, so I count the next element 4. The gap is between 3 and 4, the gap is 1. So previously between 1 and 3, the gap is 2, between 3 and 4, the gap is 1. Again, it's breaking. The gap has to be same throughout. Only then it qualifies as an arithmetic subarray, right? So 1, 3, 4 itself is not working. So there is no point in adding more and more elements to it. Okay, it's already failing. 1, 3, 4 itself is not arithmetic in nature. So by adding 5 or 6 or 7 to it, it's not going to become arithmetic, because 1, 3, 4 itself is failing. Okay, so we are dropping that. We are going to start again at the point 3. Okay, keep moving right. Okay, we got 4 here, so the gap is 1. Gap in the sense, like informally, I'm calling it gap. It's basically the difference I'm referring to. So here between 4 and 5, the gap is 1. 5 and 6, it's 1. 6 and 7, it's 1. So far everything is fine. If I count the next element 4, then it is breaking the chain. So far everywhere, 3, 4, the gap is 1. 4, 5, it's 1. 5, 6, it's 1. 6, 7, it's 1. But between 7 and 4, it is -3. The gap is not 1 anymore. It is -3. The difference is -3. So we cannot count it. And this is the first arithmetic subarray we encountered. Strictly technically speaking, it is not the first one, because we could have stopped right here. 3, 4, 5, that qualifies as an arithmetic subarray, right? So strictly speaking, 3, 4, 5, 6, 7 is not the first subarray we encountered. Okay, but let's not talk about all these things. I don't want to dump everything at once and cause confusion. Okay, so let's take it step by step. Okay, now right now, we're not interested in finding all possible arithmetic subarrays. Look at it like, just for time being, okay, look at it like we are interested in finding the longest possible arithmetic subarrays. Okay, look at it that way. How far you can go, how far we can keep moving right. Okay, so let's look at the problem that way, and then we will come to the actual number of arithmetic subarrays, right? So this is the longest arithmetic subarray we have encountered as of now. So when I say longest, I don't mean that in the global sense. I'm not saying that, okay, the longest of all the possible subarrays in the entire given array. I mean that in a local sense. Okay, let's keep finding the local maxima, not the global maxima, right? Okay, so that is noted. Okay, 3, 4, 5, 6, 7 is one subarray that we got. Okay, now we have to stop here. We can't proceed further. We cannot count 4. So at this point 7, again, we'll start counting fresh. Okay, 7, 4, the gap is -3, 1, the gap is still maintained, it's -3. And if I go ahead to -1, the gap becomes -2, right? The gap is now -2. It's breaking the chain. 7, 4, 1 is fine. Uniformly, the gap is -3, right? Whereas if I count -1, it's breaking. Okay, the gap is not -3, it's -2. So you will have to stop there. You can't count -1. So 741 is another longest. Again, I'm using the word in a local sense, right? So in this particular part of the given array, this is the longest subarray we can find. Okay, and it's of length 3. 741, it's of length 3. Okay, fine. So we will start counting from this particular point again. Okay, wherever one longest subarray is ending, that is our new starting point, right? So we start counting here. Okay, 1, keep moving right. So -1, the gap is -2, -3, so the gap is -2 still, -5, so the gap is -2, -7, the gap is still -2. Okay, so far it's good. Then count 6, the gap is not -2, in fact it's 13, right? So that is breaking this chain. Okay, so 1, -1, -3, -5, -7, that is another longest subarray which is arithmetic in nature, right? The common difference is -2. Did you get this? So this is another longest, the third longest subarray we encountered so far. Okay, so now this is where we start counting again. So where one subarray ends, that is where we begin the next one. Okay, so -7, keep moving right. 6, so the gap is 13. Keep moving right. 11, the gap is 5. Okay, so it's not working, right? So you cannot include 11. Nor you can stop at 6 because -7, 6 is just 2 elements. So it cannot be counted as arithmetic subarray. Okay, so we are not counting anything here. Go to 6. Keep moving right. Include 11. The gap is 5. Include 16. The gap is 5. Okay. Now try including 20. The gap is 4. It's breaking the chain. So you cannot count 20. So 6, 11, 16. This is an arithmetic subarray, right? And there is no point in starting at 16 and moving right because you cannot have 3 elements. So there is no possibility of having arithmetic subarray. Okay. So we're not even discussing that. So what are the longest streak of arithmetic subarrays we have come across so far? This 3 to 7. This 3 to 7 is 1. Okay. That is the very first longest streak of arithmetic subarray we came across. And then 7 to 1, this will also qualify as an arithmetic subarray. And then 1 to -7 will qualify as another longest streak of arithmetic subarrays. And finally 6 to 17, another longest arithmetic subarray, right? So we have 4 longest possible arithmetic subarrays. Local maxima we are talking about, right? And the question is, if you read the problem statement correctly, the question is, we need to find all possible arithmetic subarrays of the given array, not just the longest ones. Okay, so longest ones we have 4, but we need to find all possible arithmetic subarrays. Okay, so for that, we're going to take the following approach. Okay, so imagine we have a longest arithmetic subarray of length 6, but the question says we need to find all possible subarrays, not just the longest. Okay, so consider this particular example. I didn't even want to write the numbers. Okay, whatever these numbers are. So imagine we have an arithmetic subarray of length 6. Okay, so how many subarrays we can produce out of this particular arithmetic subarray alone? So how many further subarrays we can produce? It's very easy. The least possible is of length 3. So how many subarrays we can produce which is of length 3? 1, 2, 3, 4. So let me mark it down like 4, right? So how many subarrays we can produce of length 4? Okay, 1, 2, 3. So we can produce only 3 subarrays of length 4. Okay, how many subarrays we can produce which are of length 5? 1, 2, only 2, right? So 2. And how many subarrays we can produce which are of length 6? Okay, that is the entire array itself, which is 1. Okay, so let's add them all in order to find the number of subarrays of the given array itself. Okay, so add them all, we are going to get 10. We could have simply written it like 10, but I don't want to do it that way. Okay, let me write it in the following manner. Okay, this is basically 4 into 5 divided by 2. This is basically 4 into 5 divided by 2. I want to show you a pattern here. That's the main reason why I'm writing like this instead of simply writing 10. Okay, so now imagine we have a subarray of length 9. So previously I have given you this, I have shown you this calculation for a subarray of length 6. So that subarray, arithmetic subarray of length 6 will further have 4 into 5 divided by 2, which is 10 number of arithmetic subarrays. Okay, so now imagine we have 9 elements in the subarray. Okay, so how many possible subarrays are there for this particular subarray of length 9? Okay, so how to count it? Start with 3, the least possible number of elements that must be there. Okay, 1, 2, 3, 4, 5, 6, 7. So we can have 7 subarrays of length 3, right? Okay, now let's count the subarrays of length 4. 1, 2, 3, 4, 5, 6. Okay, so we can have 6 subarrays, arithmetic subarrays of length 4. Okay, how many are there of length 5? How many arithmetic subarrays are there of length 5? 1, 2, 3, 4, 5. You already see the pattern, right? It goes like this. So instead of just adding them numerically, right, let me write it this way. This is basically 7 into 8 divided by 2. So when we have an arithmetic subarray of length 9, then the number of subarrays for that particular subarray is 7 into 8 divided by 2. Did you get this? So for 6, it is 4 into 5 divided by 2. For 9, it is 7 into 8 divided by 2. So if you see the pattern, for example, imagine I give you an arithmetic sequence of length 30. How many possible subarrays are there for this? It has to be, if it is 6, you have to take the preceding two numbers, 4 and 5. If it is 9, you have to take the preceding two numbers, 7 and 8. So if it is 30, you have to take the preceding two numbers, 28 and 29, multiply them and divide by 2. So that many arithmetic subarrays it will have, right? Did you get this idea? So this is our strategy, and we are going to write the code for it. So first, let's create this variable called difference. We'll initialize this variable called difference, which is nums of 1 minus nums of 0. Basically, the difference between the first two terms. Nums of 1 minus nums of 0, right? Then we'll introduce another variable called count, and we'll give it the value 2. Why 2? I'll explain. Okay. And then another variable called required sum. This is our final answer, and we are setting its value as 0, right? So this is where we are going to form a for loop for I in range of length of nums. Okay, it can't be length of nums. I will have to modify it. I'll explain why. It's not length of nums. It is range of 1 comma length of nums minus 1, right? So if you notice here, I'm purposely ignoring two indices. One is the 0th index, and the other one is the very last index, which is length of nums minus 1. You know how it works in Python 3 at least, okay? Whatever number you write here, that number is not included, okay? For example, if this number is 10, it is going to go like 1, 2, 3, 4 all the way till 9. That 10 itself is not included, okay? The left endpoint is included, the right endpoint is not included. That is how it works, okay? So this is the for loop that we have created. And in every step of this iteration, we are going to find something called as current difference. It's a new variable. And this, we are defining it as follows. Nums of I plus 1 minus nums of I. So the least value of I is, according to this range specified here, it is 1. So the least value of I is 1. So if you put 1 here, it's nums of 2 minus nums of 1, which is this element minus this element. Why are we not bothered about this? We did bother about it. That is the first thing we have even considered in this entire code. Okay, so this element minus this element is what is called as difference. Okay, now here we have something called as current difference, which is second minus first, right? And likewise, when I is 2, it is going to be nums of 3 minus nums of 2, which is this minus this. When I is 3, it is going to be nums of 4 minus nums of 3, which is this minus this. Are you getting this idea? Okay, so current difference is going to give us the difference between two consecutive terms throughout, right? Okay, so what are we now going to do with this this variable called current difference? We are going to compare it with the difference. Okay, we are going to compare our current difference and difference. Current difference is something we are calculating in every single step, and difference is something we keep updating whenever there is a need to update, right? Okay, so we're going to compare the current difference and difference. So if current difference is equal to difference, then we are going to increase the count by 1. So what is even the meaning of it? What is going on here? What is going on here? If current difference is equal to difference, then we increase the count by 1. What does it mean? It means that as long as the current difference, as long as, for example, the difference between 4 and 5, as long as that difference is same as the difference between 3 and 4, I will keep moving right. Okay. And I'll keep increasing the count by one number. Okay. So the difference between 5 and 6 is same as the difference between 4 and 5. Again, I'll keep increasing the count. The difference between 6 and 7 is same as the difference between 5 and 6. Then I keep increasing the count, so on. So that way, we are going to find the longest possible arithmetic subarray. Again, in a local sense, right? Locally, the longest possible arithmetic subarray. So that is what we're going to do. Okay, the count is going to do that. The count is going to give us the length of the longest possible arithmetic subarray, right? And what if it fails? Naturally, we have to ask this question. What if it fails? What if the current difference is not same as the previously set difference value? In that case, we are going to stop counting. Whatever is our previous count, that is going to give us what? The length of the longest possible arithmetic subarray, and that particular longest possible arithmetic subarray will further have its own subarrays, each and every one of which is arithmetic in nature. And I have shown you the calculation how to find it. Okay, so this is how we are going to find it. It is the required sum. Remember, we created variable called as required sum. Required sum is increased by count minus 1 times count minus 2, the whole thing divided by 2. Remember this? When the count was 6, it was 5 into 4 divided by 2. When the count was 9, count in the sense the length of the longest arithmetic subarray, when that particular count was 9, the number of subarrays of it was 8 into 7 divided by 2. So that logic. Okay. So we are increasing the required sum by count minus 1 times count minus 2, the whole thing divided by 2. And after that, we will have to reset the count value to 2. So now it makes sense why we are resetting the count value to 2, or why did we even initialize the count value as 2? Because we are updating the count value one number at a time. Okay. And we want to consider the count value only when it is 3 at the very least, right? So the moment you find the current difference matching the previous difference, the count value becomes, default value is 2. The moment such a condition is true, it becomes 3. Okay. And 3 is the minimum number of elements that we are looking for in a subarray, right? So we want the count value to start at 3. So that is why we initialized it to 2. And that is why we keep resetting it to 2 every single time. Okay. And also one more thing we are going to reset. That is the difference value. The difference value is reset to current difference. Now let me explain this else part of the code. We have just now understood the if part of the code. So now what's going on in the else part of the code? Okay. So in if part, what is going on? We are trying to find the length of the longest possible arithmetic subarray. Okay. And in the else part, this is what is happening. 3 things are happening in the else part. Okay. So now, for example, let's consider 3. Okay. So 3, 4, 5, 6, 7. Okay. And it stops. You can't take 4. You can't count 4 because the difference is not common anymore, right? So 3, 4, 5, 6, 7 in the sense the count is 5, right? And the common difference in this particular arithmetic subarray is 1. That is a common difference. So what are we supposed to do? We are increasing the required sum value by this value, count minus 1 times count minus 2 divided by 2. That I have clearly explained. And now we are going to reset the count value to 2 because we are going to now start counting from 7 onwards, 7, 4, 1, so on, right? We are going to start looking for subarrays starting at 7. Okay. So in that case, I need to have a new value for count, which is 2. 2 makes sense. I told you why. And then we are resetting the difference value to be equal to the current difference value. You know, what is the current difference? Current difference is not 1. Please understand, how did we even go to this else part? We went to this else part because the current difference is not equal to difference. That is how we even went to the else part. So what is the current difference? We wanted to count 4 and we calculated the difference between 7 and 4. It turned out to be -3 and we compared it with the previously assigned difference value, which is 1. So the -3 is not equal to 1. That is why we even entered this else condition in the first place, right? So now if you have to keep moving forward starting at 7, 7, 4, 1, so on, if you want to keep moving forward, we should be checking the current difference with respect to the new difference value, which is -3. We shouldn't be using the previous difference value 1. It doesn't make sense. So that is exactly what we are doing here. We are updating the difference value to be equal to the current difference, right? And the particular cycle repeats over and over again till we exhaust all possible numbers, right? So once we are done with all this, in the last step, we are going to return the required sum, but we have to be a little bit careful here. Just returning the required sum is not going to work, because this is not a very good example, because the last 3 elements, if you consider, it's not forming an arithmetic subarray. Imagine the scenario that it is actually forming an arithmetic subarray. Okay, let me move this bracket over here. So imagine this scenario that it was not 20, it's ending with 21. So this is clearly forming an arithmetic subarray, right? 6, 11, 16, 21. It's clearly forming an arithmetic subarray. So whenever the given array itself is ending with an arithmetic subarray, we will have an issue with this else condition. This else condition will not get activated. We are not going to apply this particular piece of code, right? Particularly when the given array itself is ending with arithmetic subarray. This particular piece of code is definitely not going to get executed, right? When it will get executed, when this current difference is failing to be equal to the last updated value of the difference. That failure is not going to happen, right? 6 and 11, the gap is 5. 11 and 16, the gap is 5. 16 and 21, the gap is 5. It's running smoothly, right? So we will keep on satisfying this if condition and we'll keep on increasing the count. So where exactly is that else condition going to get activated for the last subarray? I mean, where exactly it's going to get activated? It won't get activated. If it's not getting activated, then you're failing to do this particular updating, this particular updation, right? That is exactly what we're going to do in the return statement itself, right? So count -1 times count -2, the whole thing divided by 2. That's it. So this is our algorithm, and let's code it out. And yeah, just one more condition we will have to include. This entire thing will make sense only when the given array itself is having at the very least 3 numbers. If the given array is having less than 3 numbers, there is no point in doing all these things. We can right away say that we can't have any arithmetic subarrays, or in other words, we can simply return 0. You can have only 0 number of arithmetic subarrays. Okay, so that condition, let me actually add it when we are coding it out. Okay, so let's now go to Leetcode and code it out and see how it works. Okay, so we are starting with this variable difference, which is nums of 1 minus nums of 0. And we introduce another variable called count. We set its value as 2. And another variable called required sum. We set its value as 0, which is actually the output required. And here we create one for loop for I in the range of 1 comma length of nums minus 1. Oh, okay. Like I told you, let me introduce another condition. That is, we even do all these things when length of nums is greater than 2. In the sense, it has to be at the very least 3. Otherwise, it doesn't make sense to do any of these things. Okay, we can simply return 0. You can't have any arithmetic subarrays, because any arithmetic subarray by definition must have minimum of 3 elements. Okay, so what are we doing in this for loop? For I in the range of 1 comma length of nums minus 1, we create another variable called current difference, which is defined to be nums of I plus 1 minus nums of I. And this value, this current difference value, we are going to compare it with the previously assigned difference value, and we are going to compare them. And if they are equal, we are going to increase the count value by 1. Like I told you, this is where we are going to keep on finding the longest streak of arithmetic subarrays, right? And when it is failing, we are going to find the required sum. We are going to update the required sum by following value: count minus 1 times count minus 2 divided by 2. And we are going to reset the count value as 2. And we are going to reset the difference as current difference. And finally, we are going to return the required sum along with this formula: count minus 1 times count minus 2 divided by 2. Along with that, we are going to return the required sum. Okay, now let's test run our code. Great, it worked. So let's now actually submit our code to see how it performs. That's good. Our solution is accepted, and also our runtime as well as memory usage, they both are decent. And I hope you understood the solution. Thank you for watching.